of the rest of the electrolyte in the cell. A second sample is drawn for the specific gravity reading. While a sample is being drawn, the syringe is held vertically so the float doesn't touch the sides of the barrel. Enough electrolyte is drawn to lift the float off the bottom of the barrel, but not so much that the float hits the top of the barrel. If the specific gravity is high, the float will ride high in the sample. If the specific gravity is low, the float will sink lower into the electrolyte. Once the float steadies, the specific gravity is read off the scale at the surface of the electrolyte. The specific gravity reading here is 1.222. This is not necessarily the value that's recorded. Specific gravity is affected by temperature, so the reading may need to be corrected for the temperature of the electrolyte. Electrolyte temperature may be checked using a cell thermometer. Here the cell temperature is 68 degrees Fahrenheit. When electrolyte temperature increases, its specific gravity decreases, because warmer liquids are less dense than cooler liquids. When the temperature decreases, the specific gravity increases. The normal or standard reference temperature for electrolyte is 77 degrees Fahrenheit or 25 degrees Celsius. To get an accurate specific gravity reading, the specific gravity is corrected by adding 0.001 to the hydrometer reading for every 3 degrees above 77 degrees Fahrenheit. For every 3 degrees below 77 degrees Fahrenheit, 0.001 is subtracted from the specific gravity reading. Some cell thermometers have a specific gravity correction scale opposite the temperature scale. The correction scale here is marked in thousandths. In this example, the electrolyte temperature is 68 degrees Fahrenheit. The correction factor for this temperature is about -3. So 0.003 is subtracted from the specific gravity reading of 1.222 for a corrected specific gravity of 1.219. This is the value that is recorded for the cell. After the specific gravity reading is taken, the electrolyte is returned to the same cell from which it was taken, and the specific gravity of the next cell can be taken. IEEE Standard 450 recommends checking pilot cell specific gravity once a month, and all cell specific gravities at least once per quarter. Specific gravity should be checked before water is added to a cell, because the water doesn't immediately mix with the electrolyte. Under normal float charge conditions, it may take 6 to 8 weeks for the water and electrolyte to thoroughly mix. In addition, specific gravity readings should not be taken during or immediately after a battery is given an equalizing charge. The reason is that it takes time for the sulfuric acid from the plates to mix with the electrolyte, so the specific gravity will continue to increase for a period of time after the cells have been fully charged. For this reason, specific gravity should not be checked until the battery has been on normal float charge for at least 72 hours after an equalizing charge. After cell specific gravities are corrected for temperature, they can be evaluated in several ways. One way is to identify the highest and lowest cell specific gravities and determine the difference between them. The difference is compared to high and low cell specific gravities from previous tests. A noticeable increase in the differences may mean an equalizing charge is needed to raise the specific gravity of the weaker cells. Specific gravity tests, if done at the right time and when properly corrected for temperature, give a good indication of the state of charge of the cells in a battery.